Hi, my name is Dr. Peter Kay, and this lecture is on the steady flow energy equation. So in this lecture I'm going to describe different steady flow systems and the differences between them. Then I'm going to talk through how to derive flow work, and it's important to understand that because that's one of the terms in the steady flow energy equation. Can also talk through, so you should be able to then describe the property enthalpy, and then finally you should understand how to derive the steady flow energy equation for yourself, and also be able to use that steady flow energy equation, SFEE for short, to solve various problems. So first, before I go on to kind of derive these things and talk about different types of systems, first, I've got to say that the steady flow energy equation, as the name suggests, only applies to processes where you have a steady flow. Now, in previous lecture, I was talking about, for example, thermodynamic cycles, so the Otto and diesel cycle. These are non-flow examples of non-flow systems. So you can see example here, an internal combustion engine is a prime example of this. So when the pistons are closed, this is a closed system, okay? And so therefore it's a closed system was an example of a non-flow system. So it's one where the fluid has a continuous boundary, okay? You can see that it's obviously trapped by the cylinder head and cylinder liner. And no fluid can enter or leave, okay? So that's a non-flow system. This equation obviously, as I said, relates to steady flow systems, okay? And a steady flow system is one in which, as you might expect, the fluid enters and leaves at steady rates. And in particular, and this is important when we come to the derivation, it's a system where both mass and energy are conserved for the system. And a good example of this is a turbine, like you might see on an aircraft wing, where you have fluid going in at one velocity, leaving at another velocity, but obviously mass is conserved, and then it's heat's being added or work's being done, or a mixture of both, okay? But the difference here is the fluid is entering and leaving this system boundary, draw that box around it, whereas here is very much enclosed or non-flow.